tool that will help us measure the actual correlation between two variables. So it's called the correlation coefficient. I bet that will be a matching kind of word. The correlation coefficient, R, tells you the correlation between two variables. Here's how you find it. So you take an ordered pair and you multiply the x and the y together. So you do that for every ordered pair, x times y, x times y. You make a column with just x times y. And then you add all of those up. So this means add up all the products of x and y. Here, they want you to add up all the x's, get the value, add up all the y's, get the value, and then multiply them together. So here you multiply, then add them up. Here you add them up, then multiply. Down in the denominator, you've got kind of, these are the standard deviations for each variable, essentially. So you've got the square root of n times the sum of the x squareds minus the sum of the x's squared. And then here you have n times the sum of the y squareds minus the sum of the y's squared. I won't make you do this either. So we'll figure out how the calculator can do this for us too. It's not real easy to compute by hand. If you take your time or use an Excel spreadsheet, it works very nicely. But your calculator can compute this. Where's it at? It's under tests. So if you look at stats and this time go over to tests, it starts rolling down. It is number F. It is number F. On mine, I don't know if it's the same on yours, but it's the Lin-Reg-T test. It says F. G is right below that, says Lin-Reg-T interval. That would be confidence interval. Okay. We're going to do the Lin-Reg-T test on this value of R. Again, what does the R tell us? So I mentioned earlier that if R is 0, like there's no relationship, nothing's happening. If R is 1, that's like a perfect positive relationship. If R is -1, that's a perfect negative relationship. So R is actually a number that is always between -1 and 1. And it's going to tell us how strong the relationship is. It's always between -1 and 1. If somebody ever gives you an R value that is bigger than 1 or less than -1, they're full of it. Okay? R is always between -1 and 1. So just thinking about -1, 0, and 1, we've already mentioned this, but R equals 0 means that there is no relationship between x and y. There's nothing going on. If R equals -1, that means that there is a perfect negative relationship. In other words, an increase in x correlates to a decrease in y. So it's like a slope, negative slope. You're essentially not going to find anything perfect, though. What you'll get is really close, like -0.9. That's pretty close to -1. Okay, -0.95 would be even closer. -0.7 is still that one that we had that they were kind of scattered but still kind of close together. I would say he's probably like a -0.6 to 0.7. If R equals 1, that would be a perfect positive relationship. So remember, positive with increase in x means an increase in y. The longer you study, the better your grade. The older you are, the taller you are. So an example of like a negative relationship, we haven't mentioned one. I don't know, number of absences in grade maybe are correlated. The more absences, the shorter your grade. The less your grade. Mine's not working today. So again, negative relationship means an increase in x gives a decrease in y. Positive increase in x means an increase in y. So really, if you think about just the absolute value, the closer you are to 1, the better you are. And if it's negative, it's a negative relationship. So the closer it is to 1, if you just want to look at the absolute value, the stronger it's going to be. So what we want to do then is we want to test the R value. So that's what we'll end up doing. So we'll say, okay, I think there's a pretty good relationship here. Our null hypothesis will be like, there's no relationship. In other words, R is 0. And then we'll try to show that R is not 0, because if it's not 0, then there's some kind of relationship. So now, again, when we talk about how good our line is, we actually want a nice percentage. We want to say, oh, there's like a 95% positive relationship here. The way we do that is by using something that's, well, it's R squared. You just take the R and square it. That makes it positive. So the regression line is used to predict values of Y based on values of X. When you come up with this equation, you could then say, oh, so if somebody studied for 8 hours, what do you think their grade would be? You could plug in an 8 and get out what their grade. We want to be able to use the line to find information like that. You can only do that if it is a good line. So how do we tell how great our line is? Well, the stronger the relationship, the better the predictions. And what we're going to do is use something called R squared. So again, this is another one of those vocab matching words you might see. What is R squared? It's the coefficient of determination. That's what it's called. Coefficient of determination. Just R before you square it is just called the correlation coefficient. When you square it, it's now the coefficient of determination. What it does is determines how well or how accurately your line will predict something. So how do you find it? You just square R, whatever R is, square it. And instead of presenting it as a decimal, it's usually presented as a percent. So remember, R is always between -1 and 1. You square it, now it's between 0 and 1. That sounds like a probability, doesn't it? Between 0 and 1. So you actually, if your R squared is 0.78, then you would say it explains 78% of the difference. So this tells you how good your line is at predicting Y values from X values. Again, we usually square it, and well, we always square it, and then we state it as a percent. All right, so let's talk about actually testing something. So what you're going to do, again, the kind of data you're getting here is 2 values from a single individual, whatever that individual is, and you think that one of the values might explain the second value. So from gathering data and computing the equation of the regression line and the correlation coefficient, we can't. Okay, so this is just saying that we can find it all and not know if it's any good. So this is kind of back to the R squared. The idea is that if you've got your correlation coefficient and it's strong enough to think there's a relationship, you want to test to see if there is actually a relationship, and we'll do that with hypothesis testing. So again, what you're going to test is R. Remember, the closer R is to 1 or -1, the stronger the linear relationship is. The R squared then will tell you how good your regression line is for guessing values. So we're actually going to use like the Greek R. It looks like a P, but that is rho. Okay, so this is rho. Again, it looks like a P. It's not a P. It's a rho like that. So you're going to perform a test on R, the correlation coefficient, to see if the population coefficient rho is either equal to 0 or not. So if rho equals 0, remember no relationship. If rho is not 0, then there might be some kind of relationship. So again, essentially what we're trying to do is determine whether there is a relationship or there's not a relationship. So our null hypotheses will always be, the null will always be rho is 0. There's no relationship between X and Y. Our alternative hypothesis will then be that rho is not 0. Or it could be, if you think that it's a positive relationship, you could say that rho is greater than 0. If you believe it is a negative linear relationship, then you could say rho is less than 0. Okay, so really we still have 3 possibilities for that alternative. But usually we're just going to do, I don't know if there's a relationship. Let's see. Okay. So as you're reading the question, most likely it'll just say she thinks there's a relationship between the two things. Let's see if there is. Okay. It won't say whether she thinks it's a positive or a negative. And so the X and Y, of course, or whatever the heck you're looking at, and then also make sure that you still write next to it whatever your claim. So maybe you're trying to show there's not a relationship between the two things, and your claim would be the null hypothesis. If you're trying to show there is a relationship between the two, then your claim would be the alternative hypothesis. We will need degrees of freedom here. You noticed, I don't know if you caught that, but this, where did we say what to use the calculator? It's called a lid reg. Goodness gracious. See the T right there? So it's a T test, which means you're going to need degrees of freedom, right? The T test. So degrees of freedom is always n minus 2. So the degrees of freedom is n minus 2. And your test, and this is T, and the way you're going to find T is by using R. So the test statistic is R times the square root of n minus 2. In other words, the correlation coefficient times the square root of the degrees of freedom divided by the square root of 1 minus R squared. Remember, R squared is kind of the probability of this being able to predict a value. So that's really the kind of the probability of failure right there, 1 minus R squared. Squared gives you like the probability of getting something right. The 1 minus R squared would be the probability of messing stuff up. So divided by the square root of 1 minus R squared. The calculator gave you R. Okay, so you'll see that. The calculator will also give you T. So we're going to have 5 steps to our hypothesis test, same as always. Step number 1, state the hypotheses and identify the claim. So the null hypothesis, rho equals 0. There's no relationship. The alternative hypothesis, rho does not equal 0. In other words, there is a relationship. Which one is your claim? I want to put that next. The next thing you're going to do depends on which way you're going to do it. If you're just going to use the p-value, and all you have to do in step 2 is state your significance level. We'll have told you that. So in step 2, it would say alpha equals 0.05. Okay? Or a critical value. Where do we find the critical value? From the t table, because this is a t distribution. I don't have a table with me. Do. Yeah. So depending on whether you're going to use p-value or critical value, that determines step 2. 3 is to find the test statistic. This is your t. It is found by doing r times the square root of n minus 2 divided by the square root of 1 minus r squared, or just writing down what your calculator tells you. Okay, that's your t. Your calculator will also give you the p-value associated with that test statistic. So remember what the p-value is. It's the probability of having found that test statistic if, in this case, rho is 0. Okay, that's what we're testing against. So what you want is for the probability to be less than the significance. Okay, so if I said, let's check it out at 5%, you're shooting for your p-value to be less than 5% in order to reject and say there's a relationship. If your p-value is too big, that means that your test statistic is more common. It happens 6% of the time, whatever. So then we don't have enough evidence to reject. Okay? If you're using the critical value method, remember you're just comparing your test statistic to the critical value. The critical value is like a cutoff point. It says anything bigger than this is crazy. So if ours is bigger than that, that means something's going on. Let's reject the null hypothesis. So depending on which method, if you're doing the p-value, you want your p to be less than the alpha. If you're using the critical value method, you want your test value to be bigger than the critical value. That puts you outside. So step 4, same as always, make a decision. Either you reject the null hypothesis or you do not reject the null hypothesis. So then step 5 is to state your conclusion. Remember, this is based on what your claim was. If your claim was the null hypothesis, it's going to sound different than if your claim was the alternative hypothesis. So make sure that you're wording this correctly. You're going to write your conclusion sentence. It'll be based on whatever your claim was. So there's really kind of 4 options for that. And if you remember the multiple choice, it always gives you 4 options. Those are the 4 possibilities. You claimed the null and you rejected it. You claimed the null and you didn't reject it. You claimed the alternative and you rejected the null. You claimed the alternative and you did not reject the null. So there's kind of 4 possibilities there. Make sure that your conclusion has to do with the question at hand, okay? It should say in there something about the original claim that you made. I shouldn't be able to read your conclusion and not know that you were testing whether age has anything to do with height. See, when I read your conclusion, it should tell me what you were testing, okay? Let's look at an example. So it says, a student wants to see if the number of times a book has been checked out of the library in the past year and the number of pages in the book are related. Seems like kind of a valid hypothesis. You know, bigger the book, maybe people don't check it out as much. Personally, I think that the X should be the number of pages, because I would think the number of pages determines the checkout and not the other way around. This is the way the question was worded, so I left it. She guesses that the number of times a book has been checked out of the library in the past year will be a predictor of the number of pages in the book. So if she were to just look in the computer and see that this one was checked out 50 times, she's going to think, oh, I'm guessing she's thinking smaller numbers. Maybe it's got less than 200 pages, whatever. Notice nowhere in here does it specify that she thinks it's a positive or a negative relationship, right? It doesn't say she thinks the more times it's checked out, the bigger the book, or vice versa. It just says she thinks there's some kind of relationship and that she could use one to predict the other. So she randomly selects only 10 books from the library, and we want to try to test her claim at a 0.01 level of significance. So she picked 10 books, and this was her data. Okay, so the first column is the number of times the book was checked out in the past year. The second column is the number of pages in the book. So now, again, the way this is worded, her X value is the number of times it's been checked out. Let's put our X values in list 1 in our calculator. So put the X values in list 1 in your calculator, and we'll put the Y values, the number of pages, in list 2 of our calculator. So you remember how to do a list. Go to Stat, and then just push Edit. And then just put these in list 1 and in list 2. If you want to clear out list 1 and list 2 first, you just highlight the L1 and push clear. Don't push delete. Push clear, enter. It'll clear the column for you. But you want to put the X values, the 21, 10, 4, 39, 30, 25, 2, 14, and 4. You guys see those okay? Make them a little bigger there. So put the first column in list 1 and the second column in list 2. So if you were finding R by hand, this is where you would now start filling a bunch of stuff in. You'd find all the products, you'd add all these pieces up, and then you'd kind of insert everything into the equation. But our calculator is going to find everything for us. Now we're also going to look at the scatter plot of this and see what it looks like. Remember, there's really no point in doing the test if it doesn't look like there's a relationship, which is what's about to happen, but we're going to keep going anyway because it's an example. We don't want to stop. So when you get all of those in list 1 and list 2, what you're going to want to do is graph it, okay? So what you're going to do is go to stat plot. It's right above your y equals button. So go to stat plot. You have to do second y equals. When you do that, it's got all these plots listed. They're turned on if they're, well, it says on and off. So just pick the first one and turn it on. You turn it on just by highlighting the word on and push enter. And then it's got a bunch of pictures. Look, there's box plots on there. Use your calculator to make box plots. Just pick the first one. It's like a bunch of scattered plots. This is a scatter plot. You'll pick that first picture. And then for the X list, hopefully you put your stuff in L1. It should already say L1. For your Y list, you would put your stuff in L2. It should already say L2. And then you can pick what kind of marks you want it to make. You can either make squares or plus signs or dots. That's completely up to you. I'm going to do plus signs. So after you fill in plot, what you're going to do is check 2 things before you go to graph it. First off, push the y equals button again, not just push y equals. And if you've got anything in there that's about to graph, it'll be highlighted. So like I have y1 equals, I have an equation in there, and the equal sign is highlighted. That means it's going to want to graph that. You don't want it to graph anything except plot number 1. So make sure that nothing on your screen is highlighted except plot 1. You can unhighlight just by going to the equal sign, push enter, and now it's unhighlighted. If there's anything you need to unhighlight, you only want, so when you look at your screen, only plot 1 should be highlighted. The next thing you're going to want to do, look at these numbers. The X values, the smallest is 2 and the biggest is 39. You might want to check your window and make sure you're going to have those values. So if you go to window, what I did for my X's, I did 0 to 40. I asked it to go by 2s. That sounded decent. And then for the number of pages, the smallest there is what, 277? The biggest is 411. So what I did is I just went 200 to 460 by 20s. I guess I could have done 440. I could have done 420. So just, okay. Put something in there that's going to represent these for your window. So again, I did 200 to 460 by 20s. That was what I did. You could do 0 to 450 by 25 if you want. Whatever you want to do, just make sure that you're going to get all this X values and all those Y values in your picture when you do it. Now that you've done that, you can just push the graph button and you're going to see the scatter plot. So it's going to be the actual picture. I'm looking at it and it doesn't look like there's any relationship whatsoever. They're just all over. If they're all over, you would need a really thick marker to cover all those up. So I'm not seeing a relationship here. But we're going to proceed with the example regardless. But usually, you saw something like that, you'd be like, okay, I don't even proceed with my test. Obviously, there's nothing going on here. But this is kind of what your scatter plot should look like when you've got that graph. So this one is actually 0 to 50 by 10s and 0 to 525 by 125s. Graph should look similar to this. And now what we'll do is, I mean, it almost looks like a straight line. Do you see that? I mean, like if I were going to try to match this up, where's my, where did I put my, there it is. To grab my big marker. See, that almost looks like a straight line. So that means regardless of the number of times it was checked out, all the books have like the same number of pages. Okay, so it kind of looks like there's a relationship, just not a good one, not positive or negative. But you can actually you can graph the line with it as well. So that was the next thing I did. I went ahead and graphed the actual line to see where it was at. So I'll show you that. This is the actual line. Now, how did I get that? Because I went to linreg a plus bx, and it gave me the equation of the line. So here's how you find the equation of the line. So while it doesn't appear to have too strong a correlation, let's go ahead and compute the regression line and the correlation coefficient, and we'll go ahead and run the test on it. So the first thing, we'll just go ahead and go to the test because it's going to give us all the information we need. Let's go to stat, over to tests, and then go all the way down to F, I believe it was, linreg t-test. It's going to ask you where your X list is, L1, Y list, L2. Don't mess with the frequency, that just stays there. And then it's got, it says beta and rho. We're not really doing anything with beta, but that's your hypothesis, so just pick the not equal 0. Don't worry about that next part, just go down to calculate. And it gives you actually a lot of information here. What we want right now is the A and the B, because that's going to help us graph the line. So if you look, it's got A is 3.2451. It says B is negative 0.3523, etc. Now remember, the equation of the line is A plus BX, so all I did was plug in the A and the B. So then what you can do is you can go to Y equals, and you can actually type that in, Y1. And you can graph the plot with the line together, and you can see it's, well, practically like a straight line through the picture. Okay, there's no real curve to it, whether it's positive or negative. So you can graph that with your scatter plot at the same time, so you can see how well it fits. And again, it doesn't look like it fits very well. The R here, the calculator told us that. I lost it. Give me back my. So it says that R is all the way at the bottom, negative 0.0936. That's really close to 0, isn't it? Right? It's negative, so it's saying there's a bit of a negative relationship. But in general, that's almost 0. That's 0.09. Okay. Which again would kind of give you the hint that there's really not much of a relationship here. Let's actually conduct the test, and the test is going to tell us the same thing we've just figured out in like 3 different ways. There's no relationship here. So what's our null hypothesis? Rho equals 0. In other words, there's no relationship. Our alternative, this is what she was kind of thinking, right? Is that there is some relationship. So that just says rho is not 0. That's our claim. So step 2 is to either state significance or the critical value. We'll just do both. Can I not keep it zoomed and go? Guess not. Yeah, okay. I went too far. All right, so step 2, our alpha was 0.01. Find your critical value if you want to go that route. You simply look at your t distribution. We're in the 0.01 for our tail. And what was our degrees of freedom? It was 8. So we've got, this is a 2-tailed, by the way. We just said not equals. We didn't say greater than or less than. So 0.01, if you look at the table, you'll get 3.355. I have plus or minus on that. We don't know whether it's bigger or less than. So, and remember, the picture's symmetric. So in order for us to have some kind of relationship, we're either going to have to be bigger than 3.35 or less than negative 3.5. We need to be out in one of those tables. Which again, I doubt it happened. Our t-value is negative 0.2658. The calculator told me that. That is not bigger than 3 or less than negative 3. It's like hugging 0 again. This is not a very good t. The probability of it is actually about 80%, the p-value. So the probability of getting these numbers when there's nothing in common, there's like an 80% chance of getting these numbers. That's perfectly fine, 80%. There's nothing crazy about that. We didn't come up with anything to disprove the fact that there is no relationship here. So we will not reject the null hypothesis. Why? Well, it depends on how you're thinking about it. Our p is entirely too big. So why? Because p is bigger than alpha. P is like 80%. We wanted 1%. Okay. The other reason why is because our t is not out past the critical value. So now we have to state a conclusion that actually has to do with books and pages. Okay. So there is not enough evidence to support the claim that the number of times that a book is checked out is related to the number of pages in it. Something along those lines. There is not enough evidence to support the claim that there is a relationship between the number of times the book has been checked out and the number of pages. If she had claimed that there was no relationship, everything would be the same except the conclusion, okay? So if she had thought, I don't think there's any difference between these two, let's see. Then the final would be, there's not enough evidence to reject her claim. See? So if you can't reject, that kind of means you accept it, right? So if the claim had been the null hypothesis here, the conclusion would be that there is not enough evidence to reject the claim that there's a relationship, blah, 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 blah. So subtle difference, but very important. And steps 1 through 4 are exactly the same. But the conclusion is different depending on your claim. So just watch that. So this is the only example that I had on here, but chapter 10 is due this evening. Was there anything in chapter 10 that was bugging you? Otherwise, we'll look at it chapter 12 homework problem. I'll leave it regardless. I'm not going anywhere. No chapter 10 questions? None? All right, so let's look at a chapter 11, or sorry, chapter 12 question. Oh, don't look. Start. All right, there's only 4 questions. All right, so this first one, it says match each scatter plot shown below with one of the 4 specified correlations. So the R's that we're choosing from here are, I can make it bigger. Here are our R's. Okay, so we have a 0.2, a negative 0.79, a 0.87, and a negative 0.10. What I might do is kind of start with the strongest ones. The strongest correlation up there is that 0.87, because he's the closest to either 1 or negative 1, right? So C should be the strongest positive correlation of the choices. So this one is a negative, right? You see that, how it's going down? That one's going to be one of the negatives. That one's going up and looks pretty good. That one's kind of all over. That one's kind of all over as well. So, okay, that 0.87, definitely this guy, right? He's the best positive one up there. That first one, oh, ooh, wow, watch that, okay. That first one is the best negative, so he must be B. Remember, the closer it is to 0 or negative 1, the better it is, okay? So now we've just got to try to place 0.2 and negative 0.1. Both of those are not real strong. One is positive and one's negative. So let's kind of look at these, and I'm going to zoom out just a little bit. Maybe looking at them from a distance, we'll be able to get, oh, I just changed the answer again. I really got to be careful about that. Just pushing up and down. Okay, so that one was B. All right, so looking at these two that are a bit of a mess, you know, this one seems kind of negative, doesn't it? That last one looks kind of negative. I don't know. No, I think the first one looks more negative. The second one looks more positive. I'm going to go negative on this one. Which one was negative? Got D. I think I'm kind of mixing them up. You gotta, yeah, I'm gonna go D on this one. And A on the last one. What do you think? We try it? I don't know if we're gonna be right or not. Those last two were tricky. Got it. All right, awesome. So start with the most obvious ones first, right? All right, let's look at this one. So this looks similar to the one we just, it's even the same question. So a student wants to see if the number of times a book's been checked out. She guesses, this time she has 11 samples. We want to test at 0.1. So I'm just going to go in and to stat, and I'm going to edit my lists because I have the old lists in here. And I'm going to put in 34, 38, 30, 48, 45, 7, 4, 8, 50, 49, and 34. In my L2, I'm going to put my Y values. So 303, 326, 387, 293, 278, 281, 391, 383, 403, oh my goodness, 278, and 354. It's always a good idea to check those after you're done. I don't feel like it, but they both have 11 in them, so that makes me feel good. So the first thing it asks for here is actually just the correlation coefficient. I would look at the picture first, though. The reason I'm going to do that is to get an idea of what my answers are going to look like. If my picture doesn't look good at all, then I'll know what to expect. So, good idea just to glance at your picture. I don't think it looks very good. So let's see what my R is. I'm going stat test. I'm going to lin reg t test and just going straight down to calculate. So the correlation coefficient, according to my calculator, I got to scroll all the way down. R, I should really just take that R equals off, so you have to know what it is. What does it say? 3, so 308. So this is what I'm getting in my calculator, negative 0.308. So notice that's a negative relationship, but it's kind of close to 0, so it's not all that great. It also wants to know the equation. Make sure you pay attention. It is A plus BX. So the A is 362.189. And the B is negative 0.885. All right, let's see. The test value was the T, which is negative 0.96. Negative, oh, whoops. 3 decimals, negative 0. Number is 9697, so that's going to make it 970. And we didn't even find the critical value. The p-value is 0.358. That's really big. That's 35%. Okay. We wanted that to be smaller than 10% was our alpha. So that's way too big. Also, if you look at the critical value, it was 1.8. We're not near 1.8. We'd have to be outside of 1.8. So we don't have evidence to do anything. We're not going to reject here. So this is, again, where it's important to know what your claim is. Our claim, I believe, was that there was a relationship, right? I didn't even. So we think there is a relationship. So that means that there is enough evidence to reject the claim. You never reject an alternative hypothesis, so that one doesn't even make sense. There is not enough evidence to reject the claim. Again, that one makes no sense because our claim was the alternative. The first two would be if your claim was the null hypothesis. The third one says there is enough evidence to support our claim. Nope. The answer is the last one. There's not enough evidence to support our claim. All right, so essentially, the calculator gave us every single answer to that. You just got to know where to put things. And then, of course, you have to know how to interpret that when you're done.